Okay, 2.1, determining average rates of change. So the average rate of change is the change in quantity represented by the dependent variable. So when we represent change in, we represent it by delta, which is a triangle. Okay, divided by the corresponding change in the quantity represented by the independent variable, again, delta x, because this is the change in, okay, over an interval. Algebraically, the average rate of change for a function y equals f at x over some interval, so we have x is between x1 and x2, can be determined by this. So just like in grade 9, when we were doing slope, average rate of change in y over the change in x, delta y over delta x. Another way of writing it, remember like the slope formula, the function evaluated at the second x minus the function evaluated at the first x over x2 minus x1. Okay, in other words, y2 minus y1 over x2 minus x1. Okay, and again, this is straight from grade 9. Graphically, the average rate of change is equivalent to the slope of the secant line passing through the 2 points, and then we would call them x1, y1, x2, y2. So this would be the first point, and this would be the second point. Example 1, given the function f at x, which is going to be this graph here, the blue graph, find the average rate of change. So we can either call it arc, and I will call it out loud a rock. Okay, average rate of change in the interval when x is between and includes -4 and 2.5. So I'm going to stop there for a second, and I'm going to locate x as -4. We go through this point here. Okay, so that is actually the point -4, comma 1. And then 2.5, I'm going to locate the point, I think that this is correct, 2.5, comma 3. Okay, then find the equation of the secant line drawn between these 2 points. So when we draw a secant line, we draw a point between, or a line between these 2 points. So as you can see, if this slope is decreasing all the way up to a maximum, then it continues to decrease, and then at this inflection point we start to increase, okay, all the way down to the minimum, and then we continuously increase. So it doesn't matter how much this slope changes over the course of between -4 and 2.5. What we're looking at is the average. So even if you took every single rate of change, which if it's infinitely many, and then you average them out, the average rate of change is going to be exactly what the secant will tell us. Okay, so you know, I'm not going to call it M, that's grade 9. I'm going to call it a rock. Okay, so we're going to do y2 minus y1 over x2 minus x1. If you need to go ahead and label these points, this is obviously x and y, and we'll call this point 1. Okay, x1, y1. This is x and y, right? Ordered pair, but now we're going to call it x2, y2. So we're going to get 3 minus 1 over 2.5 minus -4. 3 minus 1 is 2, and 2.5 minus -4 is 6.5. And if we do 2 divided by 6.5, we're going to get 4 over 13. Okay, that's just times 2 times 2. We don't usually use decimals in fractions, so we want integer values. Okay, and then as a reminder, if we have the line y equals mx plus b, we have the slope, which is 4 over 13. And let's just use one of these points. I'm going to use -4, comma 1 for our x and our y. So y1, slope 4 over 13, x -4, and then plus b. Okay, so all I did there was sub in our x value, our m value, and our y value. Okay, so 1 equals 4 times -4 is -16 over 3. And then we're going to bring that over. So 1 plus 16 over, 13. I think I said 3. I get 29 over 13 equals B. So then we can write, therefore, the equation of the secant is y equals, okay, you always want to sub in your slope, 4 over 13x, and then you want to sub in your b, which is plus 29 over 13. Okay, a positive average rate of change indicates that the quantity represented by the dependent variable is increasing on the specified interval compared with the quantity represented by the independent variable. So graphically, what that's going to look like is a positive slope. So in this question up here, we did have a positive average rate of change. We're increasing to the right. So in other words, as x increases, actually, I'm not going to write increases. I'm going to do the arrow up, comma, y increases. Now, a negative average rate of change indicates the opposite. Okay, so it indicates that the quantity represented by the dependent variable is decreasing on the specified interval. Okay, compared with the quantity represented by the independent variable. So graphically, this slope is going down. So in other words, as x increases, the y, which is the independent variable, actually decreases. Okay, and all linear relationships have a constant rate of change. You'll get into this more in calculus. Okay, nonlinear relationships do not have a constant rate of change. Okay, in other words, constant rate of change, when we're talking about a line, okay, lines have slopes. So when we take a look at slopes, slopes are drawn with like a line, right? So we have the same rate of change going all the way up, okay? Constant rate of change for any line. Okay, example 2. Given the graph of the function f at x, so again, f at x is this blue function here, state whether the average rate of change in the given intervals is positive or negative. So all we're going to do is we're going to look at the interval of x between 0 and 5. So x at 0, the graph is here. X at 5, the graph is here. This interval would be increasing. Okay, 1 and 4. So at 1, we plot a point here. At 4, we plot a point here. This would be decreasing. Okay, another way of writing intervals instead of the crocodiles is like our interval notation with brackets, 2, 8. So from 2, and don't think that this is a point. 2, 8 is an interval. It states it right here. And if you go by the trend in the chart, it's an interval. So 2 would be plotted here, 8 would be plotted up here. This is definitely increasing. Oh, so let's put this is a positive, this is a negative, and this is a positive. Okay, so for the positive or negative. Okay, 0.5 and 5.5. So 0.5 is here, 5.5 is here. This is again increasing. So this is positive rate of change. And then we have 1 and 6. Oh, this is 0. See how that's horizontal? So this is 0, okay? You can write neither increasing or like positive or negative, right? The number 0 doesn't have a sign associated with it. The number 0 is neutral. Okay, find the average rate of change for the function f at x equals x squared plus 3x on these intervals. So for a, between 0 and 1. So if we're given a function using function notation, we can go ahead and sub in 0. So 0 squared plus 3 times 0 is 0. And then we can go ahead and sub in 1, which is the other end of this, because we're saying x is between 0 and 1. Okay, I'm putting includes. The actual wording between would not include, but I'm going to include them. Okay, so we have 1 squared plus 3 times 1. So I get 1 plus 3, which is 4. Now we're dealing with the exact same question. We're dealing with the point 0, 0, and then 1, 4. Okay, so for the slope, this is the x, this is the y, and this is 0.1, and this is 0.2. So 4 minus 0 over 1 minus 0, we get 4 over 1, which is just 4. Okay, and you can put a rock equals 4. Same thing, we're going to solve for between -2 and 3. So f at -2 is going to be -2 squared plus 3 times -2, which is 4 minus 6, which is -2. Now we're going to do the same thing with the 3. So we get 3 squared plus 3 times 3, which is 9 plus 9, which is 18. So our 2 points are -2, -2, 3, 18. Okay, this is our x, this is our y, this is 0.1, this is 0.2. So y2 minus y1 over x2 minus x1. Okay, so I'm going to get 20 over 3 plus 2 is 5. I get 4. So therefore, the A rock is 4. So this is not always going to be the case if you're given an equation and you're told to find the average rate of change. But if you actually think about this, this is x plus 3. Okay, this is the graph of a parabola going through 0 and -3, and it opens up. So just randomly, when we're taking a look at this, between 0 and 1, this would be 0, this would be 1. The average rate of change here is the same as the average rate of change between, say, for example, -2 and 3, which would be from here to, and then wherever that goes up there. I didn't draw it big enough. Here we go. Okay, and those are going to have the same rates of change.